that we're trying to resolve using the software solutions that Geoff will talk about. So, the agenda, we'll first talk about Burlington Hydro overview, give you some of the smart grid initiatives. How Go 360, and especially its open architecture, helped address those needs. And Geoff will talk some more about the challenges that we've had and the enterprise solution and the network design and this thing we call asset management. And we'll also talk about some neighboring utilities and some of the other work that's going on around us. So Burlington Hydro's 65,000-ish customers, 32 substations, 1,600 kilometers of low voltage distribution lines. By low voltage, it's still 27,000 volts, but by low voltage we mean it's not transmission voltage. And 93 employees. It's roughly located here in the pink area, and you can see Oakville, Mississauga, and Toronto. That's generally called the Greater Toronto Area. For those of you that want to refer it to, USC Buffalo is down here at the bottom. So anyway, you can see where we are. Burlington Hydro's logo is in the upper right corner here. And like most utilities, we're wrestling with smart grid. What is it? How do we capture it? What do we do about it? And so we created this identity just below the Burlington Hydro logo called Grid Smart City. And the purpose for that was to draw together partners to address the opportunities and the challenges. And so we've got about 17 corporate partners connected to that, some very large multinationals, and about 10 utility partners. And with them, we've done some initiatives that you can see here, which I'll talk about, and also we're exploring how some of these things can become business opportunities for utilities in the future, and how we prepare the utility to be a utility of the future. So the first thing that we did is called automated switching or intelligent switching. It's self-healing, it's high reliability, so we took the whole core of the city of Burlington and we deployed 43 advanced intelligent switches, and we reduced the outage time. Typically in any utility setting you'd have an outage time perhaps an hour a year. We went to sub 30 seconds, about 20 seconds per year outage time in that downtown core. And there were some critical loads down there that we were addressing as part of that project. Like all the utilities in Ontario, we deployed smart meters. Smart meters coupled with time of use billing. We have renewable generation spreading rapidly in Ontario, mostly solar, but different kinds, including microturbines with gas and wind. We have electric vehicle charging, just like you do here in the U.S. Those things are showing up on our system, and they're going to challenge the system at the very end where we don't need to challenge it, mostly at the residential end. So we have to be able to deal with that. And we have these things I call factory ride-through systems, or premium power. So this system will ride an entire factory through a very short duration outage and allow their process or manufacturing process to continue in spite of a lightning strike or another short outage. And then we have battery-based electricity storage, and what we're doing with this is we're trying to understand how that can be aggregated and deployed across the grid as a resource. So we have generators that bid their price into the market, and we think that eventually storage is going to follow that same model. It's going to be bid into the market as a resource. This open architecture thing was a main requirement, and proprietary or closed system just wouldn't do it for us because we have such a diversity in the databases that we were using in other systems like SCADA. SCADA is a supervisory control and data acquisition system. That basically operates the intelligent switches and other switches on our grid. We have a whole bunch of other things that you don't really need to know about, like the meter data management and repository. That's almost a provincial thing. All the utility meter databases feed into. Very large amounts of data involved in that. And we have the integration effort, and we want to utilize some of the existing IT resources that we've always had. So it had to be open. We needed real-time bi-directional communication. So, advanced systems that manage our distribution system as it's, on, and outage management systems, they had to be able to communicate in real time with the mobile workforce that is, around the city every day. And as I mentioned, we have big data, literally billions of transaction records per year. And we have to be able to store and access a lot of this data very quickly. So Go360 provides the solution based on the Oracle Spatial database. And the live updates and bidirectional communications are part of what we're doing. The network design and connectivity model, that was a very important thing that we spent a lot of time thinking about. The next point down, asset management, is something new for all utilities. We have to literally visit every asset that's in the field every 3 years. So you basically split that up into 3-year intervals, and you go over a third of your assets. Somebody has to go there, test the asset if it's that kind, photograph it, measure it, or just record it, record the latest on it. And that has to come back in real time and be available to the other users of that data set. We have tablets, and we don't have that many iPhones in the field, but BlackBerries. People can take snapshots, our supervisors can take snapshots of an asset in the field, and it immediately goes back to the data set so that others can see what they're talking about, what they're referring to. We have outage management issues, distribution management. We have smart grid analytics. We'll go into a little bit of that in a moment here. And of course, we have this thing for executives who always want to be informed, but the executive dashboard has to draw from this information and allow them to make the appropriate decisions. Geoff, I'd like you to run a couple of those videos. Okay, this video, each circle here represents a transformer, and this is the loading over part of a day, and you can see as they go red, that's an overloaded transformer. And so this is something we could never do before because we didn't have the intelligence built in. There's many of them in this particular area. What we'd like to be able to do is to run this as part of our engineering, analytical, and planning functions so that we can upsize transformers that need a greater capacity and appropriately deploy our assets rather than have them fail, which they do when they're overloaded as much as some of these red ones are. And each day, I think there was one that was about 4% of its life used up every day just because of the rate at which it was overloaded. So with that, that's just a sample of what we can do now. I'd like to turn it over to Geoff, and he'll explain some of the workings of the system. Thank you.
So it was a good introduction. I'll take us through sort of what we've actually achieved to date, how we got there, what we were faced with when we came into the organization to start this. And I kind of want to reiterate that Burlington Hydro is known as Smart Grid City in Canada, so they were pretty much further ahead of all the other utilities, even the large utilities, thinking about where they wanted to go beforehand, which fed well into why they picked the solution, how we've been able to implement so quickly. Go360 is an application that sits in Oracle Spatial on top of MapViewer. We've built our own security and configuration engines and electric utility-based applications, everything across mobile, asset management, outage management, engineering design, that kind of thing. But what's really key, and one of the things where Oracle allowed us to do some stuff, is tie all other applications or workflows real time. Now, there's nothing like trying to make a big smart grid decision on your network and having data that's a day out of date. It just won't work. So everything that you're going to see is stuff that feeds in either from a truck in the field, grid operations, SCADA, smart metering, design, mapping. It's all going into that system in real time. And just some examples. In the middle, you can see an example of a design interface, but other applications through the web that are being generated for different uses. So everything from executive dashboards to asset inspection to smart grid analytics and other things that I'll get into in a minute as I show what's actually been accomplished today and what we're working on this year and going forward with. Burlington Hydro's systems history, a couple years ago, I think it was just 2 or 3 years ago, we started the project. They had an older cable CAD system. It wasn't a real network connectivity model, it was a parent-child relationship, so we had to take this older database that didn't have versioning, needed a bit of work, we would say, on the data cleanup and put it into the new model. And then started from there doing the integration, literally building applications. I think we delivered the first asset management application with the system so people could have access to photos, to asset detail, to queries, to reporting. Things that would take them months to do with teams of people now could be done by an asset manager in a day, just sitting at their desk and doing their reports. They have Dafron for their billing. It's their ERP system. It has asset history. It has materials management. It has time reporting, that kind of detail. They have an engineering analysis system, Dromi, so they'll do things like fault calculations, other kinds of analysis. It's very helpful in the design process. And we integrated that in real time, which is very nice. There's other asset condition data that was sitting there in paper files, other records that got converted in. A SCADA system by Surveillant, which records data every second. So it's nice to have that come in the control room. And finally, all the stuff that Burlington was working on. So the AMI, the smart meter, was a provincial legislative requirement. So they're putting in 60,000 smart meters, all in a very short time, like 6 months. And they all had to work and record and talk that. A whole EV vehicle fleet. And as Dan mentioned, the whole smart self-healing switching that was going on in the city, renewable energy and other things. So lots of different systems and some that I'd never seen before, but quite a nice challenge. And from the consulting point of view, they were looking at this from both an enterprise solution and a smart grid solution. So there are recommendations what to do, move from standalone to obviously an enterprise implementation and integration, but also benefit the utility by providing lots of rich functionality to people. So if the lineman has to use it, the executives have to use it, their operators have to use it, their contractors have to use it. Mobile workforce was key on their agenda, getting the data out of cable CAD into a properly managed model that's live and usable. Lots of system data integration amongst all those different systems. And when we're talking feeds, I think we're talking probably, in your case, I don't know, from the AMI alone, it'd be billions of records a year. I can't remember what the calculation is, but it's a lot of data. And focusing on that real time, which is where they're going to reduce all the outages and try and get as reliable as they can and extend their asset. And I really like this quote because I took this from the RFP I had to answer actually. So this is from their consultant who recognized a while ago that the web was key. And I think they recognized a while ago as well standards, because today all these standards are being developed around the world for smart grids. So substations are called IEC. There's even a common information model of what a distribution network should look like physically, how it connects. And people are writing these standards in and out to connect in real time. A lot of these legacy systems that are out there today are not real time. They're not even close. So anyway, it's quite neat, and the ability to get that data out to everybody in the organization is key, because that's where you get the benefits and the value. The main targeted implementations to start with were engineering, customer service, mobile, finance, HR. But the real key, a couple of the keys on top of that for the enterprise was productivity enhancement, streamlining the workflow, getting rid of paper, getting more accurate information. And the other nice thing was that the timing was good on this project because they just started that regulatory inspection. So we actually implemented an asset inspection solution as one of the first products as well. And this is actually what we've accomplished so far in about 2 years. We've integrated the SCADA system. We've got in a solution called Spatial and Power Design Engineering, which I'll talk about in a second. Got the CIS and the ERP integration completed, the engineering analysis completed, and the AMI and the Intelli team and other network smart sensors that are talking to the system. And it's been deployed across the organization, right from the executives to the trucks to the folks down in operations. So here's an example of design tool. It's kind of quite cool. This actually uses AutoCAD Map 3D tied directly to Oracle Spatial. So we've actually integrated CAD design with GIS network design in real time. So everything's done on the fly. And we actually have the operators now posting all the as-built changes. When they energize something in the control room, they actually post the change in, so it's always up to date. So all those changes are coming through. As I mentioned, it writes directly from Oracle Spatial, so it's seamless to the user. If you have CAD capabilities, training is really quite seamless. It's very nice. And it has all the capabilities for job management, versioning, map production, It engineers with your engineering standards. So for example, I can pick a standard because it should be built this way, it should have this framing, those kinds of things.